So what I'd like to do is revisit logistic regression. And so this is really just a building upon what we all have already done in here. This is regression. So we're looking at the effect of the independent variables and the dependent variables. Let me go to, first, let me stop sharing this for a second and go to Moodle. Okay, and so this is what I realized this was not showing up when we were talking last time, but this is where this equation down here is coming from. P stands for the probability of some occurrence, and we did go through and plug in values here like we've done before with linear regression, the values for the x's, and then you're given the a, the constant, and the b. And so it's just like linear regression, you plug in values, and what it's finding is predicted probabilities. And so I was playing with this, and I noticed that we plugged in a value of 15 for delinquency here, and it produced a probability of suspension of 0.99, and you can crank that delinquency value up higher. You can crank it up to 30, and it'll still produce a value. It'll be up to 1, and it won't go above 1 because it can't get above 1, because the probability of something happening can't get above 1. That's saying 100% chance of something happening. And down here we had it at a different profile, a different statistical profile, producing a lower probability of some outcome happening. And so, yeah, the logistic regression models that we're working with, the dependent variable is coded 0, 1. Here, this part 5 is where I would like to go to first is this. I'm asking you to look at delinquency, recoded 0, 1 as a dependent variable, include gender, and this picture vocabulary, test results, and report on model statistics. Okay, that I think we've done already. Let me do something else. Instead of this, let me look at the effect of some of these variables, gender and AHPVT and delinquency, on the odds of being suspended. And I'll add in one other one in there too. I'll add in ever repeated a grade, and we'll add in a variable on trouble in school. So we'll add in all those and interpret that output for being suspended from school. Okay, so we'll do that. So how do we do that? All right, let's take a look at back into SPSS. So we want to take a look at ever been suspended from school in logistic regression. And we want to control for multiple predictors or have multiple independent variables. And so to do that, we go to where it says regression, and where it goes to where it says linear, we go to that. Oh, I'm not linear, I'm sorry. Logistic regression. So let me do that one more time. People are not confused. Regression, and then we want to go not linear, where it says binary logistic regression. Okay, so let me reset this and just do this from the beginning. And so we want to declare our dependent variable as the variable for ever been suspended from school, and that is H1ED7, and that is coded 0 or 1. And we saw that last time, so we won't have to do that again, but display variable names and sort alphabetically. H1ED7 is the variable that indicates whether or not they've ever been suspended from school. Not just like suspended in the air somewhere, but suspended from school, probably from acting up. Okay, so that is what we want as a dependent variable. And then what we want to do is include additional predictors. And so I have in there that I want you guys to include delinquency as a predictor. Now, delinquency, you may or may not have that variable constructed, so I'll go ahead and not include that right now. Delinquency, though, is just the variable we constructed before. It's the scale variable, but I won't include that because then it'll make you guys construct it really quick. I'll just go ahead and include, though, let's include gender as a predictor of being suspended. Okay, and let's also include in there at the very bottom, if you have this sorted by file order, it's actually the picture vocabulary test is at the bottom, AHPVT. Let's throw that in there. And then let's also include the variable for ever repeating a grade, ever being held back to repeat a grade. And so that's H1ED5. I'm going to sort alphabetically and go H1ED5. Okay, there it is. And then there's also a variable that asks trouble in school. How often do you have trouble in paying attention in school? So that's one H1ED16. Okay, oops. Did I? H1ED16. Oh, it's back up here. Okay. Okay, so these are all predicting the odds of this occurrence of being suspended from school. And we go ahead and hit OK. Okay, so it does give you this step 0 block that's not of great value to us. What is important to point out, first off, here is this model summary. And here are these R-square statistics. There are 2 of them. There's the Cox-Snell R-square, and then there's the Nagelkerke R-square. Okay, so the Cox-Snell assumes that you are looking truly at a dichotomous variable, like ever been pregnant, are you pregnant? That's a yes or no question. There really is no gray in between there. And so that is where the Cox-Snell is more appropriate. However, if you have a binary indicator of something that you think is theoretically indicating an underlying continuum towards risk or something like that, then the Nagelkerke R-square is more appropriate. That usually shows a higher value. But just like in linear regression, this is telling us the percent of variation being explained in the outcome. And so given our predictors, the one R-square statistic is saying about 12.7% of the variation in ever being suspended from school is being explained, whereas the Nagelkerke R-square is a little bit higher. It's saying about 18.3% of the variation in suspended can be explained by our logistic model that includes these 1, 2, 3, 4 predictors. Okay, and so that's the model R-square. So that's an important thing to look at. Then we have down here the classification table. Not too important right now for our purposes. We want to look at the variables in the equation. This table here looks very similar to what you see for linear regression. The big difference here is has this exponentiated B column. Okay, this is the big difference from linear regression because this is the effect on the log odds of these variables, and the log odds is not really intuitively interpretable because it's a weird scale. But the effect on the odds of some occurrence, well, that's like gambling. That's something that everybody can understand. It has a nice intuitive interpretation. It's just you have to remember that a 1 is even odds. That means that the effect of this variable doesn't have a positive or negative effect on it. If it's below 1, that means that this variable is lowering the odds of something happening. And so here is the effect of biological sex. And so like in linear regression, because biological sex is coded 1, 2, 1 is male, 2 is female, when you go up in units of biological sex, you're moving from male to female. And so that's why it's negatively correlated with the likelihood of being suspended from school. Boys are more likely to be suspended from school. And also being female lowers your odds of being suspended in school by just a hair above 60%. Does it lower your odds? Because it's 1 minus this number. Exponentiated beta tells you the percent change in the odds. And so if it's below 1, then it's 1 minus that. And if it is above the odds, so this picture vocabulary test here, this is also significant effect. It is negative, so you know it's lowering the odds. if we exponentiate that beta, whenever you exponentiate beta, if you express beta as an exponent of the constant e, which is 2 point value, 2 point something, like look it up, it's a mathematical constant, it will always return a value that it's never negative, but it'll be 0 to infinity somewhere. And this is returning a value of 97.5. That means that for every point increase on the picture vocabulary test, the odds of being suspended drops by about 2.5%. Okay, so so for every unit increase in the score, or for every point increase in the picture vocabulary test, the odds of being suspended from school drops by about 2.5%. Now, if we have you ever repeated a grade? Well, not too many kids repeat grades, so that's probably an indicator of a major behavioral or cognitive problem. Okay, what is the effect of that on the odds of being suspended from school? Well, yeah, it is positive. We know that it's pushing up the odds. By how much? Well, it's 2.64. But you interpret that the same way. You could say, okay, it raises it by 164%, or it more than doubles the odds, or multiplies the odds of suspension by about 2.64. That's how you would say it. Normally, people wouldn't say it raises it by 164%. You could say that, but that's mathematically, it's the equivalent. It's the same thing by saying it multiplies the odds by 2.64, or it raises it by 164%. So it's just the percent over 1. That's what you're looking at. Like, how much greater than 1 is that? Well, if you're going from 1, it'd be 164.2% greater than 1. So that would be interpreted as those kids that have repeated a grade are 164.2%, have 164.2% greater odds of being suspended from school than those kids who have not repeated a grade. And so this here is trouble paying attention in school. Trouble paying attention in school, you interpret that as that is a more or less ordinal scale. How often do you have trouble paying attention in school? I think it ranges like from 1 to 5. And so every unit increase in that is the impact on the log odds. But again, we want to interpret that in terms of the impact on the odds, the exponentiated beta. And so for every unit increase in having trouble paying attention in school, the odds of being suspended from school go up by about 38.3%. Okay, and so that is the interpretation for your exponentiated betas, where B is expressed as a power of the constant E, and that is usually what people want to know when you're talking about some outcome that is dichotomous, that's measured in a binary format, 0 or 1. Okay, and so if you want to use this equation to predict the probability of suspension for some certain set of characteristics, then a real easy way to do that, you can actually you can just cut and paste like this, and you can then post that right into Google, and then use, you would want to go back and use this equation. I'm not having you do this on the homework, but you would post it into this equation here, where you have the whole equation expressed as a power of E, okay, divided by, in parentheses, 1 plus that whole equation again. And so that's how you would get to the predicted probability, given some settings for your variable. So you'd want to set your predictors, your betas, all those numbers that are given to you at some level. So biological sex. So if you'd want to say, okay, I want to know the predicted probability for a female, okay, so you would set that, you would have that multiplied by 2, plus a negative, let's say I want to have it at the average level of the picture vocabulary test, and you find what the average that is, and then have it multiplied by that. For people who have not repeated a grade, and so since repeated a grade is measured 0, 1, you'd have to multiply that by 0 for people who have not repeated a grade. And then plus this trouble paying attention in school, you would choose at whatever degree you'd want the trouble paying attention in school to be at. Now, if you want to push up the odds of being suspended in school, you would probably assign that, you would have to assign that a high value from however trouble paying attention in school was originally coded. And so you can find that out by just looking at how it was coded. And it was coded never, just a few times, about once a week, almost every day. So it's a 0 through, it's a 5-point scale. It's 0 through 4. And so you have 0 through 4 as what you could plug in for the values that are going to be multiplied by these predictors here. So notice when you're using the equation to find predicted probabilities, you are using these unstandardized betas, and here's the constant or A, what you plug in for A. So you use this when you're doing predicted probabilities, but when you are interpreting the effect of each one of these individual independent variables on the odds of the dependent variable occurring, then typically you want to look at the exponentiated betas. You want to talk about them in terms of the percent impact on the odds. Okay. So, okay, questions about anything that I went over there? The homework, what I'm asking you to do is just to make some logistic regression model that explains at least 10% of the variation according to either one of these R-square statistics. Okay. You don't copy the one I did just now. If you want to use suspended from school, that's fine. But please include some different predictors other than the ones I just used. So any combination of other ones is fine. You want to use some of the same independent variables, fine. Just something that is not identical to what I just now have on screen is all legitimate to use. But that's your task, and then you don't have to do predicted probabilities. I don't think I'm asking you to do that. I'm just asking you to report on how you interpret all of these exponentiated betas for your predictors. Yeah, that's the assignment. Now, this is the constant here is not really interpretable, so you don't need to mess around with that. That is only really part of if you're graphing it to know where the maximum likelihood is at of the odds of this occurrence happening when all of these variables are at 0. But this is not too terribly interpretable. So we don't really want to interpret the constant for this. We just want to use that only when we're trying to find predicted probabilities.